Hello, I would like to talk you through a small example to do CRUD operations with Python against DataStax Astra. We'll be using this repo, which is DataStax examples, CRUD with Python and Node, but we'll concentrate on the Python code today. The Node is very similar. It's all in the README. It's actually a pretty detailed README. And let's start with this table of content here. The first step is to set up a database in Astra. If you haven't done this before, you would need to go to the login screen. You can get here by clicking on this link to astra.datastax.com. Or if you already have an account, you can just sign in. And then you get to a dashboard. And I'm here already. I don't have any databases at the moment. So I can either add a database here, or I can click on this button. And let's get started with that. We'll be using the free tier, which is hosted on Google Cloud. And since I'm based in Europe, I will go with this region, Europe West 1. But you pick whatever is closest to you. And then we can configure. Now, this is entirely your choice, but we've tried to make life a little bit easy for you by giving you some default values, which we've also populated in our code examples. So you want to stick with that, you have the least changes to make in your code. But they're pretty simple changes anyway, so you can choose what you like, really. So I'm calling this my Astra cluster. Then we need to select a key space name. We'll be using spacecraft key space name in this example. The example is about recording small journeys by spacecrafts and their telemetry data. So this is appropriate. And the user is as user. And the password is as password1. And then you can create the database. This will take a couple of minutes. Currently, the status is pending. In a couple more minutes, we should see it as active, and then you can actually start using it. It's coming on. But I think in the meantime, I'll show you the other component we'll be using in this demo, which is we will use an online IDE, Gitpod, which you can start straight from this GitHub repo. So you can click on this one here, and then you can open this in a new tab. And this might take a couple of minutes as well. It's basically creating the Docker containers in order to host this environment for us. While this is working, let's have a look and see active. Perfect. This is what we want. Good. So there's a couple of setup things that we want to do in the database before we actually start writing code against it. And one of this is that we want to create the schema for our database. We will be using the CQL console to do that. So it's logging me in as the user that I've created as user. And here I am. So we want to make sure that we use the right key space. So use spacecraft. You see that the prompt here changes to the spacecraft key space. And then we'll take the schema from the README here in the GitHub repo, right? So just copy that out. Keyboard shortcuts, Command C in my case, and paste that in with the Command V and let it complete. Okay, so that looks good. Clear the console to get a bit more space. Describe tables. And I now have 5 tables set up. So I have the spacecraft journey catalog. This will basically hold, details about individual spacecraft journeys. And then I have 4 tables that record telemetry data, like pressure over time, speed, location, and temperature over time. Okay, so that's pretty much all we need to do with the schema. In the meantime, let's have a look whether our Gitpod is up. It is up, and I think I'll make that a little bit bigger. So hopefully that's easier to read. So Gitpod is basically just pulling everything from the repo into this IDE. And we will be working with the Python code that is in this directory, CRUD Python. Let's go in there. Okay, perfect. You can also see the readmes from here, right? So we can look at here what we want to do next. So this is I think it might be easier to read if I show it to you in the proper GitHub repo. Okay, let's go here. Right, so there's another thing we need to set up, and that is we need to set up the driver connection to the database. And for that, we need to have all the security credentials. And we can get them from Astra as well. So we go back to our Astra database. We can go to the summary here and select connect, which gives us a couple of options how we could connect. We could REST API or GraphQL, but we want to connect with the driver. And you see here, I have here the ability to download a secure connect bundle. This is basically a zip file which includes all the credentials. We don't want to download it into my host machine. I want to use it on Gitpod. So I'll just copy the address, copy the link address. And then I go to Gitpod and I'll curl this into this directory. So I curl -L. Make sure you use double quotes. Paste this really long link. And then redirect this to creds.zip. You can name it anything you like, but this is pretty short and sweet. So this is successful if you've downloaded about 12 kilobytes. If you have less than that, your link might have expired. This link here is only available or valid for 5 minutes or so. So if it expires, you can just reload it and then take a fresh copy of that link to make sure you get a valid bundle. Okay, but this looks good. Let's have a look whether we have it in here. Yeah, there you are, creds.zip. Cool, good, let's get started. So the exercises are numbered, exercise 2, 3, 4, 5, etc. But before we can do anything, we will need to define the connection object. So this is in here in DB connection py. And you see here we have the class connection, which establishes a cluster instance, which connects via the secure connect bundle and the credentials and connects to that key space. So we want to set that up correctly. And here it comes in handy if we've used the default values that we've used when we set up the database. Basically, this is here the path to the credentials that we just downloaded. Here's the username and the password and the key space. So if you chose anything different, you would want to update that here. But that's the only place where you need to update that. Okay, good. So in Gitpod, we have a nice terminal here. So let's clear this, make this a bit bigger. Cool. We're now going to exercise 2. And we want to do a basic connection test, right? So we just want to see, we just pull something, from the database. This is a system key space, so there's always something in here. And if we get a successful connection, print it out. And if not, tell us, a little bit about the mistakes. And then close the connection. Okay, let's do this. Python x.2 and manage. Oh, I forgot to install the driver. Of course, let's do this first. So do pip install Cassandra driver. There we are. Perfect. Sorry about that. Let's try this again. Do Python and the starting exercise. You're now connected to the cluster cars cluster. This is just the internal name that Astra is using. Success. Perfect. We are all done. So this is the basic connection test. Let's start something a bit more interesting. We do an insert. So this is a basic create statement. Right? Look at that a little bit. So we're basically, in our connection session, we're executing a very basic statement here. Insert into spacecraft journey catalog. We give it a spacecraft name, journey ID, and then we pass these parameters, spacecraft name, journey ID, false, and a little bit of a summary message. We set up the journey ID up here, the spacecraft name here, and we'll be using this. We'll be using a hard-coded UUID here because we will be reusing it in all the other exercises. But as you see here from the comment, you would really want to create your own time UUID here for your own individual journey. Okay, let's run this. Python x3, insert the journey, starting exercise, and it's telling us the journey was created for this UUID. If we want to, we can now check in Astra. Go back to our console. Wait for it to log in again. Use the spacecraft key space again. And then we select all from the journey catalog. And there we are. We have inserted a record. So that's a basic, very basic create statement. Exercise 4 updates this record because we want to be alive, right? We want to be on our journey. So we want to update the journey status to true. So and then we say we have taken off, right? So we use again a very simple statement here. So we use update spacecraft journey catalog, set active to true, and then we're setting a start time. And in this case, we're preparing the statement. So we're preparing this as an update, passing it the prepared query, which is the recommended way if you deal with a lot of queries of the same type. It's kind of like a template that both the driver and the database know about. And this speeds up execution. And then we execute the prepared statement with those bound parameters. Okay, and there we have the current time. So let's clear this up and do Python EX04 take off. And it's taken off. And again, we can see that we have the same record, but it's been updated, right? Active is now true, and we have a start time. So this is the basic update, but it's using a slightly advanced concept, which is the prepared statements over the simple statements. Next step is the most interesting module of all of them. So this uses a couple of concepts. How to do with UDTs, with user-defined types, and also with batches. So it might be worth looking a little bit more into this. We've explained it in detail in the README. So if you go to this 2, 4, 5, you can find quite a little bit of explanation here about those things. I'll show you just where to look in the code. So here we're setting up a class for the UDT, the location object, where we're defining the X coordinate, the Y coordinate, and the Z coordinate. And then later on, in our location statement, we're actually reusing that. So we're using the location. So the location here, and then we're passing that class into that class instance into it here, location of X, Y, Z, right? Okay, and then we're using the concept of a batch statement, which basically bundles the different individual statements together into a single atomic update. So we have a batch statement, and then we add these additional statements in there, and we're using those prepared statements for it, and then we execute the batch. So that Python ex05. Perhaps before I execute, I should sort of tell you what's happening. We are basically simulating the telemetry data here. Right? We're going to simulate 1,000 updates, all for location, speed, temperature, and pressure. Right? And we have some simple sort of like logic here to make that a little bit interesting, to give you some values. But we're going to insert basically 4,000 records into the database now, 1,000 into each of those 4 tables that store the telemetry data. Let's see how that works. I've got a bit of a sleeper here in order to sort of like simulate the traveling. And let's get started with that. There we are, we're traveling. And we can actually check what's happening in the meantime. So we can, for example, do a select Astra from spacecraft temperature over time. And there we go, we've got already loads of data. You can Control-C out of this if you want to. Okay, so that worked. And that's done. And that was all for that spacecraft journey. So the next one is, again, just a simple statement where we are completing the journey. So we want to update with an end time of the journey and set it to false in terms of active. Right, so we're updating this spacecraft journey, set active false, and create an end time there. Okay, so there's nothing magic there, but we just want to complete the journey. So Python 6, and it has landed. Perfect. We can go back and have a look. And now we have it all completed. The end time has been updated, and we had a start time, and it's set to false again. Cool. So this is all that we have in this exercise for updates. So we have creates and updates. We're actually not showing a delete here, but a delete works very similar. Now let's focus our attention to the read statements. First of all, we have one here, which is very similar to what I've just sort of done in the console. We're just selecting everything from spacecraft journey catalog, but in this case, we're actually specifying the spacecraft name, right? And we've been using the Crew Dragon Endeavour SpaceX names throughout this example. And then we print that out. Let's do that. So it's a very simple read. There you are. We only have one journey, right? So we only see one record. So this is perhaps worth highlighting. This is pulling out all the journeys for that spacecraft name. So if that spacecraft went onto several journeys, it's pulling out the entire partition for that spacecraft name. Let's go to this one here. So this is a little bit more interesting. We're looking at the details for a particular journey. So we're selecting again from the journey catalog where the spacecraft name matches, but now also we're specifying a particular journey ID. And then this illustrates a little bit how to parse your rows that you're getting from the database. So you basically can select based on the column name, right? So we want to row journey ID, row spacecraft name, summary, active, start, end. And we want to print that out. So let's have a look at that. Python 608. There we go. And that's putting out all the details for us. The UID, the name, the summary, and all the other details that we set. Okay. Let's look at the metrics, the telemetry data that we collected, right? So again, this is just sort of like parsing this out for the row and is adding a little bit of additional details here. So we're just numbering the rows. You know, we've got a counter in here that we're increasing, so like as a row counter. And then the time, the reading time, the row speed. And this is just focusing on one of those telemetry tables, which is the spacecraft speed over time. And again, it's pulling out very specifically for one spacecraft and one journey ID. So that. And that's number 8 and number 9. And that is probably not so useful because it's just pulling out all the 1,000 records in one row, right? So depends whether that's what you wanted. Personally, I don't find it that useful to have that much data in one swoosh, which leads to the next example, which allows to read in with paging, where we want to page through all these examples. So this is exercise 10. And here, it's basically getting a paging state from the output. So the output is what we're getting, so basically the row information, what we're getting from this exercising the statement. The statement is select star from spacecraft speed over time, where we're selecting specifically the spacecraft name and the journey ID. And we are specifying in our statement that we want to have a fetch size. We want to only pull 10 records. We only want to fetch 10 records. So we're passing that with the statement. Then we're executing this statement, which with this fetch size. And in our output, we get an additional information, which is the paging state. And we're using that paging state as a pointer to pull the second page. Here's the second page we're pulling, the same statement again, but this time we're specifying the paging state to start where we left off with the second page, right? So if all goes well, we should actually get 2 pages, one with 10 records and the second page with another 10 records. Let's try that out. Python 10. There we are. We've got 2 pages. Page 1, 10 items here, and page 2 with 10 items. And they're not the same, right? So the first page and then the second page. And that was it. I hope you find that easy to follow. And I encourage you to try out the node, which is exactly the same kind of examples in exactly the same kind of logic and order. And they're very similar. So any details are sort of like highlighted in the README. But yeah, that concludes this little walkthrough. Thank you very much and enjoy.